Hello everyone, welcome to Mathematical Method Unit 1. This video we're going to focus on 3D and we're going to learn using the turning point form, of quadratic to draw parabola. And we know parabola, it is the graph of quadratic. Okay, so now to start, a very basic quadratic function will be y equal to x squared, and we know the graph going to be look like a U shape upward. Okay, and then y equal to x squared, x and y, and the turning point, which is the origin, 0, 0. Okay, if I can draw a lot of different quadratics, so this one, and they all will have one turning point. Okay, and then I have another one, and let me draw it over here, and turning point is over here. Okay, so now in general, a quadratic could be ax squared plus bx plus c. Okay, and this is the general form. This is general form. And today we are going to focus on the turning point form, which is another form to write quadratic function. Okay, so it looks like a times a minus h squared plus k. Okay, so this one is called turning point form of quadratic. Okay, what make it special and called turning point form of quadratic is because this form tell us the turning point straight away. Okay, so they see this one h and k. Okay, so my turning point h and k, this is the coordinate of turning point. Okay, for example, if I have y equal to 2 times x minus 2 to the power of 2 plus 3, okay, and we know, and if let me write the quadratic form over here, turning point form, y equal to a times x minus h to the power of 2 plus k. Okay, so now you just compare this formula, this rule, we compare this to our turning point form. So h will be my 2, okay, and k will be my 3. Okay, so then that tell me hk is equal to 2 and 3, so which is my turning point. Okay, turning point. This is how you identify the turning point from the turning point form of quadratic. Now, sometimes it can be a little bit tricky when it comes to the positive. Okay, so what does it mean? Let me give you a different example. So let me write y equal to the turning point form again. Y equal to a times x minus h plus k. Okay, a times x minus h to the power of 2 plus k. This is the turning point form, as we know. Now let me give you a different example. Y equal to 2, okay, and x plus 4 to the power of 2 minus 3. Okay, so now it's a little bit tricky for this one to identify your h and k. Okay, now look at over here, the turning point form. It is minus h. Okay, so only that single h after the minus sign, that is the value of h. So over here, it is the plus. It doesn't look exactly like your turning point form. So when you identify turning point, you need to change your rule, the quadratic, into make it look exactly like the turning point form. So for example, this one I'm going to change it to 2 times x. Okay, so here it is minus, so I'm going to do minus. But if I do minus 4, it's going to change this whole equation. Okay, but we don't want that to happen. What we can do is we can do another minus 4, okay, to the power of square. So you see here, this minus coming from the formula minus. Now I have negative 4. This, we know this minus minus still give me x plus 4. It is still the same with the one on the top, the original turning point formula. Okay, and then let's do minus 3. Okay, so now this one we can easily tell my h, it is negative 4, okay, because we need to have one negative so that we can make it look like exactly like the formula over here. So now my h is equal to negative 4, okay, so k gonna be your negative 3, okay, k gonna be your negative 3, so k is negative 3, and as a result your turning point gonna be negative 4, negative 3. This will be your turning point, okay, of this quadratic. Okay, now when we finish the part to identify turning point, using turning point form to draw the graph, okay, and it is quite straightforward. Okay, so we can summarize into 4 steps. Okay, so let me say, using turning point form to draw parabola. Okay, your step 1, okay, you need to identify the turning point. Okay, identify the turning point. And in step 2, after you identify that, you label the turning point on the graph. And step 3, check the a value. Okay, and we're gonna come back later. And step 4, find x-intercept and find y-intercept. Okay, so now let's go to do one example on your booklet. Example 21, example 23, actually 23. Okay, so which is on your page 13. The question is asking you to sketch the parabola y equal to 2 times x minus 1 to the power of 2 plus 3. Okay, so now what I usually do is I'm going to write my turning point over here. So a times x minus h to the power of 2 plus k. Okay, because this one helps me to identify my turning point. Okay, so now, so I know h is equal to 1. Okay, it doesn't include that negative sign because negative sign is over here, so we don't need that. And then we will have k is equal to positive 3. So now by compare these two, we can identify the turning point just by reading, just by observing the quadratic form. So turning point, we can tell straight away. Turning point. What happened? Turning point. Turning point. Okay, turning point, it is 1 and 3. Okay, now turning point 1, 3. So we finish the first part, identify the turning point. Okay, so now we're going to label them on the graph. So label them on the graph. And let me do 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, make the scale. Try to make the scale accurate. So now 1, 3. So 1, 1, 2, 3. Okay, so that's my turning point. Okay, so we finished this step 2. Now coming to the step 3, A. Okay, so now we know A is equal to 2. Okay, so now A is larger than 0. Okay, so this is why I need to add it here. When A is larger than 0, we know the graph is upright. Okay, so it is it's like a U shape. Okay, and then when A is smaller than 0, and we know graph is inverted. Okay, so gonna be like an N shape. Okay, and we know A, in this example 23, A is equal to 2, which is larger than 0, so the graph gonna be upright. Okay, so we know, like roughly, I know the graph gonna be look like this. Okay, it's not accurate, but at least we identified the general shape. Okay, so this is done. To make it even more accurate, then we need to find x-intercept and y-intercept. Okay, and we know to find x-intercept, we need to let y equal to 0. Okay, and for this one, we actually don't need to find x-intercept. Why? Because we know the graph over here, it is facing up. Okay, so there was never get the chance to cross the x-axis, so we don't need to do this part. Okay, and we just need to find y-intercept instead. To find y-intercept, we let x equal to 0. Okay, we let x equal to 0. So now coming back to the formula, originally we have a equal to 2 times x minus 1 to the power of 2 plus 3. Now let x equal to 0, so y will be equal to 2 times x is equal to 0 now, so 0 minus 1 and then to the power of 2 plus 3. Okay, so now we just need to simplify and calculate 2 times. Okay, now in the bracket 0 minus 1, it is negative 1, so it becomes negative 1 to the power of 2 plus 3, and continue, so negative 1 to the power of 2, that will give me a positive 1. Okay, because negative 1 times negative 1 is positive 1, so that gives me 2 times y plus 3. Okay, and then we'll get 5. So that tells us my y-intercept is equal to 5. Okay, so now coming back to the graph, this is the graph that we put as a draft. Okay, but we are not sure where the y-intercept it is, and then but after you do the calculation, you know y-intercept is equal to 5. Okay, so now this is the time you need to go back, so let me get rid of it, keep the turning point, and we know the turning point, y-intercept is equal to 5, so it's on y-axis. Okay, so that'll be 1, 2, 3, 4, 5. That's my y-intercept. Okay, and then we can draw a more accurate turning quadratic, which is a parabola graph. Okay, so this is how you do it. Now let's do one more. Next example, so we can do example 24. Example 24. Okay, so now sketch y equal to negative x plus 1 to the power of 2 plus 4. Again, first of all, just write the formula, the turning point form over here. Okay, now we know here it is plus, it is minus, so we need to do something to make them the same. Okay, and we know k is equal to 4. Okay, now what about a over here? It is negative 1. There's no number, but you need to know here it is the 1 hidden over here. We just did not write it. Okay, so it is negative 1, so that tells you your a is actually equal to negative 1. Okay, so now you know your a is equal to negative 1. Okay, and now your k is equal to 4. Now what we need to do is we need to change this equation to make it look exactly like your turning point form. Okay, so now let me rewrite it. So y equal to negative x plus 1 to the power of 2 plus 4. So now we need to write this into negative. Okay, so that will become negative x minus 1. Okay, so now your h is actually this negative 1. Okay, rest of it gonna be the same, plus 4. So that's why we can tell your h is the one after minus sign. Okay, so that is your negative 1. So we identified h is equal to negative 1. Okay, so as a summary, we can say turning point will be equal to h and k, which is negative 1 for h and k it is 4. Okay, so that is my turning point form. So coming back to check our step, so we identified the turning point form. Next step is label the turning point form on the graph. Okay, so now we can draw a Cartesian plane. Okay, and 1 2 3 4 1 2 3 4 1 1 2 3 4 1 2 3 4. Okay, so turning point is negative 1 and 4. So negative 1, positive 4, 1 2 3 4. So that is my turning point. Okay, now let's come back. Step 3, we're going to check the value of a. Okay, so value of a, because a is negative 1. Okay, so negative 1, so that means a is less than 0. Okay, that means the graph is inverted. Okay, so it's reflected. Instead of facing up, this one gonna opening down. Okay, so we know in general the shape gonna be look like something like that. Okay, but it is not accurate. To make your graph accurate, we need to find the x and y intercept. Okay, so up to step 3, so to find x-intercept, alright, and we let y equal to 0. Okay, so we let y equal to 0. Your equation quadratic is y equal to negative x plus 1 to the power of 2 plus 4. Okay, so we let y equal to 0, then we look at y equal to 0, and then will be negative x plus 1, okay, plus 4. So now you just need to solve out the value of x. Okay, so now here we have positive 4. Okay, so we want to get rid of it. We can do minus 4 on both sides. Okay, so therefore minus 4 cancel out, and then on the left hand side we will have negative 4 equal to negative x plus 1 to the power of 2, and that negative and negative we can cancel out, so the equation become 4 equal to x plus 1. Okay, now you see here we have a square. To get rid of that square, we need to do the opposite of square, which is square root. Okay, so we do square root on both sides. So square root and will be equal to square root 4, and square root cancel out your square. Okay, so that will have x plus 1 on the right hand side. Now on your left hand side, square root 4, and we know that can be square root 4 can be equal to positive and negative 2. Okay, so now that gave me two different equations. So x plus 1 can equal to positive 2. Okay, and x plus 1 can also equal to a negative 2. Okay, or then if we solve it out, so this one x will be equal to 1. In another case, x will be equal to negative 2. Minus 1 give me negative 3. Okay, so that tells me my two x-intercept, one is 1 and another is negative 3. Okay, so that will be 1 0, negative 3 0, because it is your x-intercept. Okay, so now 1 0, which is over here, 1 0, and the negative 3 0 is 1 2 3, so that's your negative 3 0. Okay, so now you find your two x-intercept. Now remember we said to find y-intercept, we need to let x equal to 0, okay? So now originally y equal to negative x plus 1 to have 2 plus 4, okay? Now we let x equal to 0, so y will be equal to negative x equal to 0, so it becomes 0 plus 1 to the power of 2 plus 4, okay? To simplify, it will be equal to a negative 1 plus 4, which is negative 3, positive 3, okay? So y-intercept is 3, okay? So to write it as a coordinate pair form will be 0 and 3 because it's y-intercept. Okay, so now y equal to 3, so that will be 1, 2, 3, that is your y-intercept. And now you can redraw your graph parabola. Get rid of the draft parabola. Now redraw one. Connect all the x-intercept, turning point, and make sure you label them 1, 0, and this is 0 straight, and your turning point is negative 1 and 4. Okay, so this is how you draw the graph. Okay, now sometimes your turning point form, the quadratic doesn't look very similar with your turning point form. Okay, for example, your example 21. Okay, so sketch y equal to x squared minus 3. Okay, again, we can just write the turning point form a times x minus h to the power of 2 plus k. Okay, so now let me rewrite it. Y equal to x squared. Okay, so now we know for y equal to x squared, the number in front of x squared, there is actually a 1. Okay, so now we can leave that 1 over here, and in your form, turning point form, there is x minus h within a bracket. Okay, but in our the original equation, we don't have that h. Okay, so which means your h is equal to 0. To write it, so that will become x minus 0. Okay, so we can write in this one. So you see this look similar with your turning point form, but it is x squared. Okay, it doesn't change anything. Okay, and we can write the rest of it, which is your minus 3. Okay, minus 3. So this is equivalent y equal to x squared minus 3, and then we write in this form so that we can identify our turning point. Okay, so now just by comparing this form and our turning point form, okay, so now I will know my a is equal to 1. Okay, my h, it is 0. My k is negative 3. Okay, so k is negative 3. So now we know turning point will be 0, negative 3, because that's my h, that's my k. Okay, and then put them on the graph. 0, negative 3, 1, 2, 3. Okay, so now we know that's my turning point, and your a is equal to 1, which is positive. Okay, so that means the graph is upright. Okay, so then roughly we'll have this. Okay, so by looking at the graph, we know this turning point is actually also my y-intercept, okay, where it crosses the y-axis. So we just need to find that 2 x-intercept. Okay, so to find x-intercept, we let y equal to 0. Okay, so now we let y equal to, originally we know y equal to x squared minus 3. So y equal to 0 and we just need to solve out x, okay? So minus 3, get rid of that, so we're gonna do plus 3 on both sides, which will give me 3 equal to x squared, okay? So x will be equal to positive and negative square root 3, okay? So now that tells me we have x-intercept square root 3 and another x-intercept negative square root 3. So then this will be negative square root 3, and this will be my positive square root 3. And your turning point, as we identify, will be your 0 and negative 3, okay?